they really mean.
All right, so now that we have learned about basic economic concepts, let's review them in the next couple of videos. And so let's begin with exercise 1. So given is the following inverse demand and supply function. So the demand is 8 minus q, so that means it starts at 8 and has a slope of negative 1. So let me draw that in there.
At whose end there will be only one survivor.
So it starts here, ends there. Maybe let's make it a little bit bigger.
Again, in perfect competition,
outline.
no one has any market.
Not color, weight.
And that phenomenon, or that assumption, or that characteristic creates many
and we have the
welfare implications. And that
supply function which starts at 2
ultimately make sure that
and has a slope of 1
within society is
so let's also make that a little bit bigger,
at least theoretically, to the best available outcome. And another important concept is market clearance. So in a
so now we can see that the equilibrium price is 5. Equilibrium quantity is 3, so that means if we plug in here 3, we get 8 minus 3 is 5, and if we plug it into the supply, we get 2 plus 3, which is also 5. Okay, so now let's fill out that table.
That was just some preliminary
and
overview of some, what economics and competition is.
So at the price of 7, what is quantity demanded? Well, that's 1. But what is quantity supplied at the price of 7? That's 5.
Before we go into other things.
So that means we have excess supply of 4 and no excess demand.
Let's stop here and let's continue
just put in
demand and quantity demanded.
So at the price of 6, quantity demanded is 2.
Okay, so
quantity supplied
obviously consists
is 4.
of demand and supply, but
and we still have excess supply of 2.
Actually quite complex, so let's start by talking about demand.
Then at the price of 5,
important concept.
Quantity demanded is 3, quantity supplied is 3, so that's the equilibrium, so we have neither excess supply nor excess demand, so that's the equilibrium. At the price of 4, quantity demanded is 4,
so what is
quantity supplied is 2,
between demand and the term quantity.
And now we don't have any excess supply, but now we have excess demand of 2.
This entire curve. So the demand
at the price of 3, quantity demanded is 5,
so the demand schedule
and quantity supplied is 1. So now we have excess demand of
the demand
4.
Is this entire.
Okay, so now let's move to the second exercise, which is actually one of my favorite ones because it reviews again also the determinants of demand and supply very well. Okay, so here we have a demand function,
but when I say at the price,
and it is the demand function for light bulbs, and it is given by 6, and now we have to add here either a plus or a minus. And then we have 2 times the price of a light bulb, and then again plus or minus 2 times the price of electricity, and then again we have to find the right sign here, because then we have like here the parameter 2 times the price of C, which is a candle, and we have income. So we have,
so we go to 6, quantity demanded is 4. At the price
so this is the demand for the light bulb, and the light bulb is a function of the price of the light bulb. And what do we know about the relationship between quantity demanded and the price of the light bulb? Well, it's an inverse relationship. So when the price of the light bulb goes up, then quantity demanded would go down, or if the price of a light bulb would go down, quantity demanded would go up. So it's an inverse relationship, meaning we have to put in here a negative sign.
What that means is that if somebody wants to
What about E, the price of electricity? So electricity is a complement to the light bulb. So if, let's say, electricity becomes more expensive, do you demand more or less light bulbs? Well, probably less. And so therefore we have here another negative relationship. So PC, that's the price of candles. If the price of candles goes up, well then I demand less candles, but more light bulbs. So if the price for candles goes up, quantity demanded for light bulbs goes up, so that's a positive relationship.
Your individual demand function.
And now for income, we need to know if income is an inferior good. If it's an inferior good, then as income goes up, quantity demanded would go down. But if it's a normal good, then we would have a positive relationship. So, and here it says, assume that light bulbs are normal goods, so this becomes a positive sign as well. Okay, so now we have identified the correct signs, and so now we know that initially the price of electricity is 2. So the price of electricity is 2, the price of a candle is 1, and income is 1,000.
And that is somewhat captured in that.
So now what we can do is we can now take the demand function and simplify it, because the objective is to draw it into a graph where we have the price on the y-axis and the quantity on the x-axis. So the objective is to draw something like this, but of course we need to know what is the intercept and what's the slope. So we are close to getting this. So now we can just get 6 minus 2 times P, B, which is the price of the light bulb. So now minus 2 times 2, that's minus 4, plus 2 times 1 is 2, plus 0.004 times 1,000, that's 4. Okay, so now that simplifies to 6 minus 4, that's 2, plus 4, that's 4, plus 4, that's 8. So now we get 8 minus 2 times the price of the light bulb. Okay, but this is the demand function. If we want to draw it in a graph like this, we need to get the inverse demand function. So what's the inverse demand function? We just solve for PB. So we need to get from this equation 2 times PB. We need to put 2PB to the left side of the equal sign. Then we get 2 times PB, the price of the bulb, equals 8 minus QD. Then we divide by 4, and then we get P equals 4 minus 0.5 times Q. Okay, so what is the demand function? So the demand function is, I just write here not inverse demand function, P equals 4 minus 0.5
the dependent variable.
Q.
So we say
And
that
Q equals 8 minus 2 times the price of the light bulb. That would be the demand function. But this is easier to
we
draw.
say that the quantity demanded
Okay,
depends on the price.
so now let's take a look at another scenario.
Would then be the independent variable.
So now in the scenario 2i, it says suppose income doubles. So now the only thing we need to change is that instead of 1,000, we have here now 2,000. And what we know is that when income increases, we said it's a normal good, then the demand curve shifts to the right. So now let's see that at work. So now our demand function is Q equals 6. That still stays the same, minus 2 times PB, minus 2 times 2, so that still stays the same, plus 2 times 1, that hasn't changed. But now we have to add 2, because, we have to add 8, because 0.004 times 2,000 is 8. So now, if we collect terms, 6 minus 4, 2, 4, 8, 12. So now we get 12 minus 2 times PB, so that would be the demand function if we rearrange terms so that we have PB to the left side, then we would get 2 PB equals 12 minus Q D, then we divide by 2 and we get the inverse demand function is 6 minus 0.5 Q. And you see that indeed the intercept has increased, and the slope stayed the same, so that matches a right shift of the demand. So we get 6 minus 0.5 Q.
But at this point, what you should know is
okay, so next we talk about supply.
From standard mathematical conventions. Because we say the quantity demand,
and it's a similar scenario. So we have our supply function of light bulbs, and the first we have to find again what's the slope. So there doesn't seem to be an intercept here, like here the 6, there is nothing here. So we just need to add the right sign. So, and we know that there is a positive relationship between the price and quantity supplied. So here we add the positive, then W is the wage rate of the worker, so it's a cost factor. So what do we know? When production costs go up, we know that the supply shifts to the left, so that's an inverse relationship. And PT, this is the price of tungsten. If the price of tungsten goes up, which is another input factor, then we know the supply shifts to the left, so that's another negative. So now we can plug in again the values, and what we need to do is we have to find the supply function. So now for the first scenario I, we plug in the wage of 5 and the price of tungsten of 1. So now what do we get for scenario 1? The supply function is 1 PB minus 0.5, because 0.1 times 5 is 0.5. Minus 0.5, because again another 0.5 times 1.
Because this is normally the y-axis. Now if we tilt our
okay,
head like this,
so now
I can see,
it's quite easy. So we have here PB,
and this has a slope of 1/2.
Minus 1.
So therefore the inverse demand function
and then we just solve for PB, and we get the inverse supply function. And we just put PB on the left hand side, or we just add on both sides 1, and we get 1 plus
But again, if you tilt your head like this, and you just look at Q equals 4 minus 0.5.
So,
you can see,
so next we have a second scenario.
It has a slope of 1/2.
And so now the wage rate doubles.
And the last one is Q equals
So
A
now instead of 5,
so Q
we have 10.
Has an intercept. This demand function has the intercept.
And instead of a price of tungsten of 1, we have 4. Okay, so now let's figure that out again. So we have Q equals
on one side
the price of the light bulb. So now minus 1
equals
minus 2.
Q, and then I divide both sides by 2.
So that becomes PE minus 3. So that would be the demand function, the inverse demand function, and we said because the cost went up, that's a leftward shift in the supply function. So if we invert this one for PB, you see we get 3 plus QS, P equals 3 plus QS. Okay, so now we have the function, and in the next
what we mean by a determinant of demand is
page we are supposed to draw them. So let's see what we need to do on the next page. Find the equilibrium price and quantity in each of the following cases. Okay, and then determine graphically the intersection of. Okay, so let's just see again. The scenario of I was that we had P equals 4 minus 0.5 Q. Let me just write that here again. So scenario I.
So
demand.
So again, a change in
was P equals 4 minus 0.5 Q, and the supply was P equals 1 plus Q. The second scenario
is this, and
we had
change in quantity demanded
P
is
equals
this. So that means that the only determinant of quantity
6 minus half Q
is the price. So that is a little bit important. So the only determinant of
and so that was demand
is the price.
And the supply
but
was 3 plus Q.
Can have many reasons.
Okay.
So
now if we draw a scenario I, let's draw that maybe in red.
Rightward shift and a decrease in demand is a leftward.
So scenario I is red.
So what are the
So we have our demand function 4 minus 0.5 Q.
Specifically income.
So let's draw that, insert shapes.
And then preferences and expectations.
Okay, 4 minus 1 half
price
Q.
changes of related products, specifically substitutes and complements.
So if the slope is negative 1/2 and it starts at 4, well then it must intersect at 8 here. So now let's make that
here
red.
we see an increase of demand.
And let's make it a little bit bigger.
Overlay again a demand function here. So let's
and
start with this function.
The supply function is 1 plus Q. So it looks with a slope like this.
So this is our.
And now we can read, find the equilibrium price and quantity for scenario
from here
1, and actually I should have
an increase in demand.
Maybe set scenario.
So now we need to distinguish two kinds of goods. Normally, let's say this is the
so now we can see equilibrium price is 3, equilibrium quantity is 2.
Fancy restaurants. And if let's say the price in a fancy restaurant for a meal is 6, so let's say this is the current price.
Is 2.
The current price is 6. So then
okay, let's make the other one maybe blue.
2. Well, if you become richer and you have a higher income,
Okay, if you remember in the second scenario for the demand, the only thing that changed was the income has increased and it's a normal good. So now we should see how the demand function shifted to the right.
So income
6 minus 1/2, so now we are here.
Demand and a shifter of demand. But now we got to be careful. So in a fancy restaurant, you probably go more often to a fancy restaurant if you have an income.
And the new demand function is 3 plus
Let's
Q.
say this is the market for ramen noodles.
I mean, the new supply function is 3 plus Q.
Noodles. Well, it seems unlikely that, let's say, currently instant noodles cost 2 and your quantity demanded is 6. Well, if you become richer, it seems unlikely that you are demanding now more instant.
Okay, so now we can see, if you take a look at the blue one,
but if you become
we can
richer,
see that the equilibrium price is 5.
It comes to instant noodles, your demand function for instant noodles probably goes down.
And the equilibrium quantity
is, the case,
is still 2.
Inferior good.
So now what has happened is basically the demand shifted, but the supply went down. The quantity stayed the same, but the good became scarcer and has now a higher price. And
inferior good.
And when we can see if the things become more expensive, how it shifts the demand to the left. I mean, how it shifts the supply to the left. But if people have more income and it's a normal good, we can see how it shifts the demand to the right. Okay, let's stop here and let's continue with those multiple choice questions maybe in the next video, so that the videos don't become too long.
So in other words, the increase